I once had an enormous spectrum analyzer, HP851B/H551B. The weight is 58 kilograms, and it has a possibility to have an additional mixer, an outside mixer, if you want to measure higher than 10 gigahertz. And I now have another spectrum analyzer that the highest frequency has 1.5 gigahertz, and I want to have such additional mixer too. So I have found an article, I give the link below, and I made this small piece that is an external mixer. What is in it? It's a piece of waveguide with a block on it. In the block is made a hole, drilled a hole, and there's a diode in it. And I think I had the diode from a cannibalized PCB of an LNB. I now have to put some signal in here, and the signal is also coming out here when it mixes with something that's coming in here. And as you see, this is 24 gigahertz, so I have to connect here the spectrum analyzer as well as the signal source. Of course, I don't have a signal source with 24 gigahertz, so I use this NWT 6000. I discussed it before, and I put it on the frequency divided by 5, so 4800 megahertz. And at that frequency I have only a very limited amount of power, but let's see if it works. So this is the situation now. NWT 6000 output is going to here, and here is the mixer, the external mixer. When it hangs this way, the polarization is vertically, and it mixes the incoming signal and multiplies it, and also the 24 gigahertz signal, and then it goes all to the input of the spectrum analyzer. Looking at the spectrum analyzer, we see of course the whole span from 0 till 1500 megahertz, but we want to have the offset frequency, so we key in offset frequency 24000 megahertz, and then we have immediate here from 24 gigahertz till more than 25 gigahertz, if it all works. Then we have the transmitter, the test transmitter we have in this area, so we have to use only a small portion of this frequency. So we key in start frequency 24050, 24050 megahertz, and as stop frequency 24150 megahertz. So we have here a span of 100 megahertz starting with 24050. And when we add now the transmitter, we have the transmitter here with the waveguide output, and I must of course take the same polarization as the measuring mixer, and if I add it, you see here a very small peak, so we can increase the sensitivity a bit by putting the attenuator to 0, and here you have the frequency. When I switch the frequency here from this to this frequency, you see that it shifts. Another thing you don't see are the sound carriers. The sound carriers are more than 20 dB down, so therefore you don't see them, because the total vision here is only just above 20 dB. So result, it is nice to check frequency and what happens, but it is not very sensitive. What you could do to have a more sensitive mixer, likely a more sensitive mixer, is buying a Doppler module CDM324. That one has a DRO, so it's not as stable as with a multiplier, but you can make, of course, an injection of your local oscillator yourself, but you can also use the DRO for rough measurements. Okay, that's this experiment. Maybe next time a more successful one. And in the meantime, enjoy these high frequencies. See you.